Imagine a substance so volatile that the microsecond it touches anything, it violently explodes. Now imagine that same substance comes with a price tag of hundreds of billions of dollars for a single gram. This is antimatter. It's the exact physical mirror image of our normal world, identical in mass and spin, but with an opposite electrical charge. When matter and antimatter meet, they annihilate, turning nearly 100% of their mass into energy. According to our current understanding of physics, the Big Bang should have produced a perfectly balanced universe, exactly equal amounts of matter and antimatter. But if those amounts were equal, every single particle would have found its mirror twin and destroyed itself. This radiation catastrophe would have left the universe empty, containing nothing but leftover light. Obviously, that didn't happen. For every 1 billion perfect annihilations during the Big Bang, exactly one solitary matter particle somehow survived. Every star, planet, and person in existence is made from those leftover particles. We exist because of a 1 in a billion accounting error. And at CERN, scientists are building the most expensive technology on Earth to figure out why. This search happens deep underground at CERN. This facility houses the world's only antimatter factory, designed to reverse engineer that universal glitch. Manufacturing antimatter begins by accelerating normal protons to 99.93% the speed of light. Once they're at speed, researchers slam them into a target made of iridium, the second densest element on Earth. That kinetic impact is so violent it forces energy to condense into a shower of new particles, creating antiprotons in a fraction of a trillionth of a second. But generating the particles is only the first step. The real engineering problem is containment. You cannot let antimatter touch the physical walls of a container, or the experiment ends in an explosion. To solve this, scientists use a penning trap. It employs superconducting magnets and electric fields to create an invisible cage in a near-perfect vacuum. Suspended at temperatures close to absolute zero, the particles are held perfectly still without ever touching a surface. Suspending the most volatile substance in the universe inside a levitating magnetic void is a staggering technological feat, but it's the only way to study why matter eventually dominated the universe. Holding antimatter is just the baseline. To solve the mystery of our survival, scientists have to find a difference, any tiny behavioral gap between antimatter and the matter we're used to. This is the goal of the G-bar experiment. Researchers are taking ultra-cold anti-atoms and literally dropping them to observe the effects of gravity. While everything we know falls downward, some theories suggest antimatter could be gravitationally repulsive. G-bar is testing whether antimatter follows the same rules, or possesses an anti-gravity that makes it fall upward. The drop test is incredibly delicate. The anti-atoms must be frozen to a few microkelvin above absolute zero to ensure they are perfectly still before they are released to fall. Even a tiny deviation in that fall would shatter the assumed symmetry of the standard model. It would show that the laws governing matter and antimatter are not identical, revealing the specific mechanism that allowed a universe full of stars and galaxies to survive. While these gravity tests continue, containment technology is advancing rapidly. CERN researchers can now successfully store trapped antiprotons for over a year. This stability means we can finally move the substance. Scientists have already begun loading magnetic traps onto trucks to ship antimatter to research institutions around the world. But you don't need a billion-dollar laboratory to see antimatter in action. You can find it in your local grocery store. Because bananas contain trace amounts of a radioactive isotope called potassium-40, they emit a single positron, an antimatter particle, roughly every 75 minutes. This process is happening inside you, too. Due to natural isotopes in our own tissue, the average human body produces about 180 positrons every single hour. If you're fascinated by your status as a walking cosmic anomaly, hit the like button and share this with another survivor of the Big Bang. Comment below if you've ever thought of yourself as an antimatter factory, and subscribe for our next deep dive. We've built massive underground complexes to study how the universe survived its own creation. Yet while we look for a crack in the mirror of the early universe, the substance that should have prevented our existence is quietly popping into being inside our own bodies every single hour. If you've made it this far, thanks for watching. Please consider subscribing to Deep Dive Daily, hitting that like button, and dropping a comment below.